Okay, it didn't let me pause the video, so I just did it on a calculator. So for 9 months, the interest is $19.58. For 6 months, it's only $10, $10.08. Um, so obviously it's better to pay it off in 6 months because it's a lower interest rate and lower time. Okay, so the difference is like almost $9, which is what is it? It's like eight something. The difference in interest. So that's the difference. Okay, letter B is asking, does the interest rate increase at a constant rate? No, because the first 3 months it goes up 0.5%, right? First 3 months. Then the next 3 months it goes up 0.1%. Then the next 6 months, 12 months, 18 months, 6 months, it goes up 0.1%. That's not a constant rate. So it's like, you know, it's sort of random, it seems. Okay, so the answer is no. Let's see. Number 11 says, what does it say here? It says, suppose you earn 3% on a $1,200 deposit for 5 years. Explain how simple interest is affected if the rate is increased by 1%. What if the time is increased by 1 year? Well, let's do, so this is number 11. Let's do case 1. Case 1 is, let's see, well, it's I equals PRT. So the interest that you're going to earn is the principal, it's $1,200 deposit. The rate is 3%. We're just going to put 0.03, it's 3%, for 5 years. 5, right? And what's that? I need another calculator. That's case 1. Case 2 is, what if the rate is increased by 1%? Well, in that case, it's I equals 1,200. So instead of 3%, I went up to 4%, 0.04 times 5. Okay, so it's going to go up a little bit more. And then case 3 is 1,200 times the original 3%. And now what if we increased it by 1 year, so we went to 6 years? Okay, so they just want you to do those 3 calculations. So you could pause the video and copy this or something. So case 1 is the original situation. Case 2 is if we increase the percentage by 1%, 0.03 to 0.04. And case 3 is if we increase the year from 5 years to 6 years. So you just have to do the calculator on those. Okay? Number 12. Dustin bought a $2,000 computer with a credit card. The minimum payment each month is $35. Each month, 1% of the unpaid balance is added to the amount he owes. If Dustin pays only $35 the first month, what will he owe the second month? Okay, so the key here is each month 1% of the unpaid balance is added to the amount he owes. So if he owes $2,000, right? 2,000. If the first month he pays $35, how much is left on the principal? If he pays $35, what's left looks like $19.65. He still owes $19.65. The second month he's going to owe $19.65 plus 1% of the unpaid balance. What's the unpaid balance? $19.65. That's how much he didn't pay. $19.65. So he owes $2,000 originally. He pays $35 the first month. Okay, so the first month he pays $35. Okay, so on number 12, he owes $2,000. Okay, let's say in the first month, they add 1%. So they add 1% of 2,000, which is 0.01 times 2,000. that becomes 2,000 plus 20. So the first month he owes 2020. It says in letter A he pays $35 for the first month. If he pays $35, that reduces the balance to looks like 1985. Yeah, 1985. So so the balance is now 1985 after 1 month, but then they add 1% of that. Okay, which means they add 1985. 1% of 1985 is $19.85. So he's going to owe the second month $2,004.85. I'm assuming that the first month they add some interest on the first month. That's what I'm assuming. Some credit card companies will give you like a 30-day grace period, but I'm assuming in this case they don't give you a 30-day grace period. But I'm not sure how they do it. If they do it, then you have to do it a different way. So this is what he's going to owe for the second month. Owes the second month. What he owes the first month is this is what he owes the first month. Okay, so the reason he owes that the first month is it's the original $2,000 plus 1% because it's been sitting there for a month. Okay, then at the end of the month he owes that. Then he pays $35. He writes a check for $35. That leaves with $19.85. But then in the second month, the end of the second month, they add 1%. They add 1%. Here's 1%. Okay, 19.85. If you add that, he owes 2004.85. Okay? If Dustin makes the minimum payment, what will he owe the third month? Well, he made the minimum payment. Let's subtract 35 because the minimum payment is 35. Okay, so what's 2004 minus 35? 14 minus 5 is 9. We took a 10, made it a 9. 9 minus 3 is 6. 1969.85 is what so that's after he paid. But then you have to add 1% onto that. You have to add 1% onto that. So it's 1969.85 plus 1%. What's 1%? Easy. It's 19.70 basically. $19.70. 5, 8%, 5, 1. 10 and 9 is 19. 8, 9. Looks like 1989. This looks like what he's going to owe the third month. 1989. So his balance is dropping, but not very much. That's what it looks like to me. Again, it depends on if they calculate interest beginning of the very first day, which I assume they were going to do that for this problem. So this is what it looks like he's going to owe the third month. Okay. 35, drop 35, add 1%. So it's like every month, you have to add a percent for the month it sat there. Then the payment is subtract $35 because that's the minimum payment. Okay, so it's like it's going the amount he owes goes up because of the 1%, but then it drops by 35 because he's making minimum payments. So that's kind of how you have to do it. 1% of what? 1% of whatever the last balance was. Okay, and to get 1%, you just move the decimal 2 places. You multiply it by, 2 places. You just move that decimal 2 places to get, that's 1%. Okay, number 12. Reason inductively. Compare the two investments below. Which will have a greater account balance in the given time periods? Explain. Well, what you have to do then is do I equals PRT, right? So which I equals PRT is going to, the principle's the same for both. It's $1,500 for both. We're doing number 12 right now. See how it's $1,500? The principal, 1,500, 1,500. So for both principals is 1,500. So that's easy. The rate is lower here, but the time is higher. The rate is higher, but so we just have to figure out, since P is the same for both, we just have to see which RT is higher. The RT of investment A, so here's A, here's B. A, the interest rate is 3%, so 0.03, and the time is 30. For B, the R is 4.5% or 0.045, and the time is 15 years. So which one is bigger? Well, I can do this inductively by saying that 30 is the same as 15 times 2. So let's just call this 15 times 2. Okay? 2 times 0.03 is 0.06. So this is really 0.06 times 15. This is 0.045 times 15. Obviously, this is bigger because the 15s are the same. So 0.06 is bigger than 0.045. Okay? So A is the better investment. Then, meaning it will have a greater account balance. Because even though the interest rate on B is bigger, because it's 4.5%, because the time is 30 years, it's longer. Okay? It's double the time. That makes more interest. Okay, it's bigger. Okay, so you don't have to like multiply it out. You could just see by doing a little bit of math here, okay, that A is going to grow bigger. How much bigger? Well, this is 0.06 times 15. That's 0.045 times 15. So the 0.06 wins. I think that's it.